Welcome everybody to my oral report on the project I'll be doing for our capstone class. So for my project, I'm going to be focusing on the links between diabetes and Alzheimer's. And my name is Nate Winters, if you don't know me. So I'd say in the last pretty recent history, and concerning disease and new pathologies, the term type 3 diabetes has come about. And type 3 diabetes really just means Alzheimer's that has come about due to the effects of diabetes. And as we've talked about in class a little bit, and as we've wrote about in our journaling, diabetes is a very vicious disease that affects a ton of American people and a ton of people throughout the world. Um, and as a lot of us researched and wrote in our journals, also causes a huge financial effect on the people that have it, with paying for insulin and paying for different things to treat their symptoms. But diabetes here, as we're going to talk about, it even does worse, and it can cause Alzheimer's, which can severely affect the quality of life and also affect the quality of life of those of family members and loved ones of the patient. So, just for a little bit of background, glucose, it's the preferred energy of the brain. So, when we eat something that has carbohydrates, our body's able to metabolize it to glucose, which then glucose, the monomers, as you can see here, they're going to enter our cells and be metabolized through glycolysis, produce ATP, and our cells are going to have energy to do the things that they need to carry out the metabolic functions that keep us alive. Glucose, it's very important for the brain. Glucose is what the brain wants. It can run off of other things we'll talk about a little bit later, but when the brain doesn't have glucose, the brain really struggles to adapt to different forms of energy. So, in terms of diabetes, generally speaking, insulin resistance comes about. So, for those of you that are unfamiliar with insulin, insulin is a hormone. A hormone is something that is released by the pancreas in this case that is going to get in the bloodstream and bind the cell receptors of cells so that when it binds, cells will let in glucose. If insulin doesn't bind to cells and the signal isn't propagated, then cells don't let in glucose very well, and the glucose remains in the bloodstream unused for energy. So the pancreas, like I said, it's the one that's releasing insulin, and it'll release this when blood sugar levels are high, so glucose can enter the cells. As we talked about on the last slide, glucose entering brain cells, neurons, is very important for the function of our brain. And there's a lot of things that the brain needs to do with memory, with learning, with making connections, with our balance and muscle coordination. So if our brain doesn't have a reliable source of energy entering, then we could be in trouble. And what happens with diabetes is insulin resistance happens throughout the body in our cells, but specifically with type 3 diabetes with Alzheimer's, uh, we're seeing insulin resistance specifically in the brain so that glucose can't come in and support the metabolic needs of the brain. So for my aims of my project, I want to first understand better how we can improve the brain's sensitivity to glucose. So as we talked about, when the brain is now insensitive to insulin, when it doesn't respond to insulin, glucose can't enter the brain, and that's going to cause lots of problems for the brain's preferred functions. So I'm going to first going to talk about and find ways in which we can possibly enhance the brain's insulin sensitivity so that those signals can be propagated so sugar can be allowed into the brain. So it has its preferred form of energy, as we talked about. So another thing that happens with type 3 diabetes, when the brain isn't running off the correct amount of energy due to lack of glucose, you have microglial cells that do not function properly. So microglial cells, here's just a animation of one. They're essentially the garbage crew of the brain, and they clear up cellular plaque and debris that can impair the brain's function. So when these guys aren't working properly, you're going to have a lot of buildup in the brain of things that shouldn't be there, and this can get in the way of neurological activity. It can block dendrite. It can start to degrade neurons. It can make them less sensitive. It can make signals be propagated slower. So I want to research ways in which we see if there's any data as to how we can possibly improve microglial health, or if there's been any tests done to that would suggest that they're beneficial in preserving the microglial health and function. And then the third aim is I want to possibly find diet strategies, find data for diet strategies that work to make up for diminished glucose metabolism. So, for example, if we can't get insulin sensitivity back in the brain, I want to see if there's any data that suggests that there's different diets that can be high in ketones that can possibly make up for glucose and fuel the brain when glucose is no longer an option. And as I talked about earlier, our brain prefers glucose, but in some cases, it might be better just to find something that works and have, let's say, 60 to 70% of our brain's optimal function than none. So here I have some foods that are high in fatty acids that are going to have ketones. It's this functional group here. Our brain can metabolize ketones um, to a degree. So I'm going to search and find data and see if there's been any success with maybe shifts in diets that have helped people with type 3 diabetes or Alzheimer's that's been induced by diabetes to have better cognitive function. And possible areas of research that I may consider, depending on how much I find on other things, which I feel like I'll have plenty of things to talk about with what I've already talked about. And I don't want to, pack the project so full that I don't really get a hit on anything specifically. Possible other areas of research are blood barrier damage. So with diabetes, high glucose levels in the blood chronically can affect the health of vasculature of veins and arteries, and it can also, if our veins and arteries are damaged enough, it can affect the blood-brain barrier, which, when the blood-brain barrier is affected, this is the barrier that does the screening of what can enter the brain. And it make sure that toxins don't enter and things that can be harmful to the brain. So if this gets damaged, then the brain could possibly have toxins enter that could further impair its cognitive function. So this is another area which I may consider. And then here, AGEs or advanced glycation end products clearance. So AGEs or advanced glycation end products, these are made because of the high glucose level in the blood. This happens when proteins or lipids or other molecules get sugars attached to them. And when these accumulate, they can accumulate in different organs and block a lot of functions and be inhibiting to a lot of important functions. So I may consider looking into how these advanced glycation end products affect brain activity if they're able to enter the brain. But thanks for listening. I'm really excited to get more into this research. Diabetes is a huge problem. Alzheimer's is a huge problem, and I think it'll be enriching to understand more the connection between these two and see if there's any ways that we can possibly help with patients that have these conditions. But thanks so much for listening, and I'll see you in class.